In this video, we will solve some more problems on linear motions. So first problem is, if a piece of stone is thrown vertically upwards with a velocity of 98 meter per second. So first question is, how long will it rise? How long will it rise? So if I draw the whole scenario, this is the stone, and the initial velocity we throw with this stone is initial velocity equals to 98 meter per second, and the stone will rise its maximum height h and then come down to the ground as well. First of all, we have to find out how long will it rise. So we let it take t1 time to go this maximum height h. So first of all, we have to find out the t1. So we know for t, or for go the initial position to the maximum height, is t1 equals to v naught by g. So here our initial velocity v naught equals to 98 meter per second, and we know the gravity g equals to 9.8 meter per second square. This is the standard value we actually always use. So the total time is 10 seconds. So the time taken to go from this A position to B position is 10 seconds. Now the second question. The second question states that what will be its velocity after 4 seconds? What will be its velocity after 4 seconds? We know the equation is V equals to V naught minus GT of vertically thrown upwards uh, body. We know this equation. Here I have to find out this V after t equals to 4 seconds. After t equals to 4 seconds. So if I put value like v naught equals to 98 meter per second, g equals to 9.8, and the t value is 4 seconds. So we will get v equals to 58.8 meter per second. So after 4 seconds, the velocity of this stone will be 58.8 meter per second. Now the third one says that how long will it take to come back to its starting point. So it says that how long it will take time to go to A to B and then come from B to A. So this whole path, for this whole path, we know the equation is, the total time, the equation is 2 v naught by g. So if I put all the value, like we know the value of initial velocity is 98 meter per second, and for the gravitation is 9.8 meter per second square. If I calculate this thing, I found 20 seconds. So from this manner I solved 3 problems. Now coming to the second part, second question. The second question states that a body is thrown from the top of a tower of 180 meter height. At the same time, another body is thrown vertically upward with a velocity of 60 meter per second. When and where will the bodies meet? So that means this is the height. This is the height of a tower T, height of a tower H. So that we represent the height of the tower H, and here I throw a body, like a body is thrown from the top of a tower. So I throw a body from the top of a tower, and the height of this tower is 180 meter. And at the same time, another body is thrown vertically upwards. So vertically upwards. So another body is thrown vertically upwards. So one body is thrown from the height h, and another body is thrown vertically upwards with a velocity of 60 meter per second. So initial velocity of this vertically upwards body is v naught equals to 60 meter per second. The question is where and when the body will meet. So let we consider at x meter from the ground the bodies will meet. So this height is x meter from a to b, this height is x meter. So this b to c this will be 180 minus x meter, 180 minus x meter, and at t second at t second the body will be met. At t second the body will be met. So now we derive two equations, for one for the freely falling body and another one for the body thrown upwards. For freely falling body, solution for freely falling body, we get the equation is for the freely falling body, as we find out that it takes 180 minus x meter to reach at t second. So we can write that equation is, we know the equation is for freely falling bodies h equals to half of gt square. So for h we replace this h as 180 minus x, so we can write this 180 minus x equals to half of g t square, half of g t square. And for body thrown upwards, this is our equation 1. For body thrown upwards, the equation will be as it takes x meter to reach the b point. So we can write that we know the equation for freely falling body of h equals to v naught t minus half of gt square. So here for the represent of h, we will represent the h as x, and for v naught we know the value of v naught is 60. So we write this is 60t minus half of g t square. So from that we'll get, if I add these two equations, the equation 1 plus 2, then we'll get 180 minus x plus x equals to half of gt square plus 60t minus half of gt square, which will be equals to, that will be cut down and this will be cut down, then 180 equals to 60t, or t equals to 3 seconds. The value of t equals to 3 seconds. Now we get the value of t, and now I have to find out the x, the value of x. So if I put this value of t in the equation 2, putting the value t equals to 3 at equation 2, we get x equals to 60 into 3 minus half of 9.8 into 3 square, which will give us the value x equals to 135.9 meter. So we solve the equation and we found that after 3 seconds it will meet at the height of 135.9 meter from the ground. So these two body will be meet each other after 3 seconds from the from 135.9 meter from the ground. So we solve the second problem also. So that's all for today's video. In this lecture, we first of all we learn what is mechanics. Then we learn about linear motions. Derive some equations from these motions equations, and now we solve some problem statement of motions. So this is an important chapter. We have to understand this chapter very we have to understand this chapter, and this chapter will help us to understand more about physics in our further lectures. That's all for today's video. Do subscribe to our channel and like this video. Thank you.